So again, on page 312, you see several key concept boxes there. Those are the rules that I'm talking about, but instead of trying to get you to write down those rules, which will make no sense to you, I will put them, for the most part, in actual English words that you'll understand. That first key concept, though, they're talking about negative exponents. You never leave a negative exponent in your answer. So you might see something like x to the negative 2 as we go through this chapter. That's okay as you're working through the problem to have negative exponents. Just make sure you don't have any when you get done. So if you have a negative exponent on the top of a fraction, you simply put a 1 there and take that to the bottom. That's what the rule states. You got a negative exponent at the top, just put it in the bottom of the fraction and make it positive. Likewise, if you started off with a negative exponent in the bottom, or if you got to the end of your problem and you had a negative exponent down there, just take it up to the top. And of course, that's over 1, which you don't have to show that. So that is the first rule there with negative exponents. Sometimes you'll still have something in the top. Like here, the x squared, that's fine. You don't need to move that. But the y to the negative 3 needs to go to the bottom, so your x squared will stay on the top, and the y to the third is the only thing that you're going to move in that case. So basically, what that rule is stating is don't leave a negative exponent in your answer. Move it in the last step if you have one. The next rule deals with multiplying, and the rule is when you multiply with the same base, you add the exponents. I will say that many times. You need to get that in your head. You need to be saying that every time you do the problem so that you know the rule. You need to have that memorized. That needs to be a part of your brain that you don't even have to really think about it. It just flows. When you multiply with the same base, you add the exponents. Because if you don't have that memorized very good in your brain, then when you get to a problem, you're going to have about 5 rules up there that are all going to mix together, and you're not going to remember when you do what. When you multiply with the same base, you add the exponent. So if we have x to the third times x to the fourth, what are the bases of those two terms? X. They are the same base. X to the third times x to the fourth. You are multiplying with the same base. What do you do with the exponents? So you would end up with x to the 7. You multiply with the same base, you add the exponents. Now this is a very simple example here. You can see that x to the third times x to the fourth, but it works the same if you were distributing that in there. What operation do you do when you distribute? Multiply. So you're still multiplying with the same base. So when you multiply x squared times x to the third, what would you have? X to the fifth. And then when you multiply x squared times x to the first, you would have x to the third. This should be a plus, I'm sorry. So that would be plus x to the third, and then x squared times 1 would just be x squared. So you have to keep this rule in mind as you're working through problems. Sometimes there's 3 or 4 or 5 steps you have to do. Sometimes you'll do different rules on each step. So you just have to remember all the rules as you're working through each one. So when you multiply, you add the exponents. What do you think you do when you divide? And that is true, but with one stipulation in there. When you divide with the same base, you take the smaller exponent to the larger and subtract. Why would we take the smaller one to the bigger one and subtract? Because that way you'll never get a negative number. Exactly. You don't have to do that middle part. You can just, when you divide the same base, you subtract, like we said with the multiply. But if you do that, sometimes you're going to end up with negative exponents, and then you're going to have to move those up or down to make them positive. So that's why I add that middle part. If you take the smaller exponent to the bigger one every time, then you'll never end up with that negative exponent. So if you have x to the third over x squared, now you are dividing, and both of the bases are x. So it says take the smaller exponent to the larger and subtract. Where's your smaller exponent? The top or the bottom? In the bottom. So you're actually going to bring this x squared up. So you're going to have x to the 3 minus 2, which would leave you with x to the first, or just x on the top. So if we had x squared over x to the fourth, again, dividing with the same base, take the smaller and the bigger and subtract. So where's the smaller one now? Top. You take that to the bottom. So what's left on top then? A 1. And you'd have x to the 4 minus 2 on the bottom, which would be x squared, 1 over x squared. That's how that one would end up being. Now, don't write this. Hold on. If you hadn't taken the smaller to the bigger, if you'd have just brought the 4 up to the 2, for instance, you would have had x to the what on top? You would have done 2 minus 4, which would have given you x to the negative 2. And what would you have to do with that? Move it down to the bottom to make it positive, and you would have 1 over x squared. So either way, you'd end up with the same answer, just that you have to add a step if you end up with a negative there. Confused by what? Good now? Okay. Those are the two main rules right there. Those are the ones that you really have to know, that you'll use the most often. When you multiply, you add. When you divide, you subtract the exponents. Over on the next page, one more box of rules. Power to a power is another rule you'll have to remember. When you raise a power to a power, you multiply. You raise a power to a power, which you don't know what that means probably. But when you raise a power to a power, you multiply the exponents. What we mean by power to a power is you may have x squared to the third. So you're raising x squared to the third power. That's power raised to a power. What do you do with the exponents in that case? Multiply them, so you would end up with x to the 6th power in this case. That's all power to a power means. When you raise one up to the next one, you multiply the exponents, no matter what they are. If you had a problem where it was a negative, x to the negative 3 raised to the 6th power, you're still going to raise power to a power and multiply, so that would give you x to the what? Negative 18th power. And then what would we have to do? Put that in the bottom, so you'd have 1 over x to the 18th. Now those next two, if you look, on page 314 in that key concept box. We just did power to a power. The next two are power of a product, power of a quotient. I'm not even going to really write down rules for that. What you just have to know on those is if you have several terms inside, like x squared, y to the third, z to the fourth maybe, and all of that is raised to another power, everything inside the parentheses has to be squared. It's really all that those two rules are saying. So you have to square the x squared, you have to square the x to the third, and you have to square the z to the fourth. Whatever you have in parentheses has to be raised to this outside power. So let's do that real quick. We're going to raise x squared to the second power. What would we do with those exponents? Multiply. So that would give you x to the fourth, y to the sixth, and z to the eighth. And then next one, power of a quotient is the same thing. So if you had 2 over xy squared to the fourth, all that means is everything inside there is taken to the fourth power. The 2 to the fourth, x to the fourth, y squared to the fourth. What's 2 to the fourth? Anyone? I guess one less than 16. And x to the fourth, y to the what? 8. And finally, the last rule, anything to the 0 power is 1. And I'll put this in here, except 0. 0 to the 0 power is undefined. Anything else you would ever have is 1. So if you end up with x to the 0 power, you got to know that's 1. The other thing they'll trick you up with, they'll put a whole bunch of stuff in here, and then they'll have all of that taken to 0. What would that be? Well, anything to the 0 power is 1. So in your homework, you're going to have some problems starting off that just emphasize this rule, multiply with the same base. And then you'll have some problems that just emphasize dividing with the same base. And then, of course, lastly, you're going to have problems that combine all the rules together, and you just have to use them all as necessary. That's what we'll do next. Negative 2x to the 3n. So 3n is your exponent there. All over x to the 2n, y to the third. That is all raised to the fourth power. What's order of operations tell you to do first? Anything inside the parentheses. And there are some things you can do in here. What's the next step in order? With problems like this, you can either simplify inside here first and then take it to the fourth power, or you can take everything to the fourth power first and then simplify. I'll do both up here, and I don't care which one you use. It's probably better to simplify in the parentheses first just because that is following the order of operations. But if you find the other way easier to understand, then that's the way that you should do that. So what you'll need to do, anytime you have these fractions, it's probably best if you write that out of the book and line everything up. So line up x to the 3n over x to the 2n. keep your variables in line there so you can see what you're doing, what you're dealing with. And then you don't have any y term on top, you just have one on the bottom. I would get in the habit of writing them that way. So as you're simplifying, -2/1 stays -2. There's no way to simplify that. If you had 2/4, you could, but unfortunately you don't have that. So we have x to the 3n over x to the 2n. So this is dividing with the same base. So which one of these is smaller, 3n or 2n? You would assume 2n would be, and that'd be correct in this problem. So you would take this up there, up to the top, and subtract. So you'd have x to the 3n minus 2n on the top, which is just 1n. So -2x to the n, and then we don't have anything with the y to the third. We can't simplify there, so we're just left with y to the third. Once you've simplified that, you don't have to worry so much about keeping your variables lined up since there aren't any common ones anyway. And then we still have raised to the fourth. And this is your other rule that you have to remember. Everything in here gets taken to the fourth power. So -2 to the fourth. We already did that. What was it? 16. Then we have x to the n raised to the fourth. What do you do with those exponents? Or what's that an example of? What rule? X to the n raised to the fourth. What would that be? What? Power to a power. What do you do with the exponents? Multiply them, so that would give you 4n. And then the same thing down here, power to a power would give you y to the 12th. And you're done. So the same problem, we'll do the other way first. -2 x to the 3n over x to the 2n, y to the third, all raised to the fourth. So you can take that all to the fourth power in your first step. So -2 to the fourth was 16. Then x to the 3n raised to the fourth, what would that give you? X to the 12n all over. X to the 2n raised to the fourth would give you x to the 8n, and then y to the third raised to the fourth would give you y to the 12th. So if you look down here, the 16 and the y to the 12th are already there because they're simplified. We just have to simplify this, the x terms. So we take the 8n up to the top, 12n minus 8n would be 4n over y to the 12th. So perhaps that way is a little shorter than this way, but again, it's whatever works best for you. Let's look over at your homework on page 316. Doing 12 to 26 and 30 through 36 even. Now I will tell you on 12 through about 22, those are all just one rule at a time. So those are the ones you really need to polish your skills on, each rule separately. And then starting about 24, 26, and the ones down at the bottom, that's where you're combining all the rules. So that's where you kind of have to just go along and do a rule at a time. Questions on that?